4 is polynomial and rational inequalities. If you had me for college algebra, you've already done all this, so it should be a review. If not, we'll go over it a little bit right now. Let's see. You may want to write this down if you've never done these. These are some notes about the symbols that you're going to encounter and what you need to use. If you see a less than or a greater than, this is the circles and this is the enclosing that you're going to have. So you'll have an open circle and you'll always use parentheses. If you have an equals with it, you're going to have closed circles and you're going to have brackets. If you have infinity, either negative or positive, you will also have parentheses. You're going to need that for the way you write your answer. It will make a difference. If it's supposed to be parentheses and you put brackets, it'll be wrong. Vice versa. So you need to get this down. Okay? So I'll let you get that and then we'll go to the notes. We're good? Everybody's got it? Everybody's asleep. All right. Let's go to notes. All right. Polynomial, we're going to use the calculator. You can't really do that for the rational ones, but we are going to use it for the polynomial, and that will be great. So here's an example. You have this, x minus 5 squared times x plus 2, all of that less than 0. We're supposed to come up with the solution. So what you're going to do is go to your calculator and put y1, all of that to the left over here, and put y2 to be 0. So if you'll go ahead and put that in, and you should get some sort of sketch that looks like that, and you want to be able to sketch that out on paper in order to help you read your answer. Okay? And what you want to do is find the place that it hits the x-axis. How do you do that? Second, calc, and 5, which is intersect, and you hit enter 3 times. It will take you to the first one, or one of these, and then you'll repeat it to get this one. So we need to know what these numbers are. Anybody get the one on the left? Okay. And this guy over here? Should be 5. Did you get 5 for that one? Okay. Why do I have open circles drawn where those places are? Because it's less than. It doesn't have an equal. So open circle. Also, if it's less than, I'm only concerned with the part less than the x or below the x-axis. So I have that highlighted right here. When you highlight that or make it a squiggly line or something, that's where your answer is. That's the only place it exists. So if you were going to write this, this goes from, and we're talking about the x, but forever, so to the left is what? Negative infinity up to negative 2, and I'm going to close it with a parentheses because of that open circle. And that's my answer. Anything from negative infinity up to negative 2 works in this. If you put something bigger than negative 2 in there, you won't get something that works.
So negative 2 to negative infinity would be wrong.
Right. Right. You gotta always write left to right. Okay. because you can't go, if you went, yeah, you always write left to right. I mean, I was going to try to say something there, and it wasn't working for me. All right, let's try this one. X cubed minus 4x squared is greater than 0. So this is the part that you put in the calculator. And be sure that you leave the y2 to be 0. You have open circles on these when you sketch it. Looks like that one's at 0. I don't know if it is. It should be. Okay. All right. So I've got open circles because there's no equals. I've highlighted any part of the graph that's above because that's greater. And so here's my answer. Where does it start? 4 and goes to infinity. No.
Because if you factor it, it comes up.
But it's not a rational function, so it's not an issue. Those asymptotes occur when you have one over the other and that denominator can't be 0. So you don't have anything here. This is polynomial. Okay, we're going to get to those rational ones. All right, here's a rational one. All right, this is different. You're not going to put this in the calculator. Okay, there's some steps for this. We did these. Do you remember those, Courtney? Vaguely? Maybe we've slept since then. Gotcha. Okay, you're going to find the solution of the top and the bottom. That means set the top and the bottom equal to 0 and solve them. So what would we get for the top here? X equals -1, x equals 1. Okay, so find the solution of the top, solution of the bottom. And then you're going to draw a number line kind of thing, just a straight line. And whatever you found to be here are going to be marks on there to divide the line. And so here's going to be x equals -1. Here's going to be x equals 1. They need to go in order, left to right. All right. Then we're going to define the intervals that we've got here. This is from what to what over here in this interval? Okay. And because that's greater than and there's no equals, I know I can do this. All right, inside here, what's the interval? And here? 1 to infinity. Okay, so get your top and bottom solutions, make those divisions on your line, define your intervals, because this is going to be your answer. So one of these is going to be your answer, and you'll already have it written. All right, then you're going to get test values. That means pick a number in this interval to use. And you want to pick the easiest thing. You can't use -1. Something right to the left of it, let's do -2. And in here, what would be the obvious? 0. And here, maybe 2. Now, if you use 10, that's fine, but use something as easy as possible. Now, when I say test it, that means we want to plug that number into here. Okay? So, -2 plus 1 over, what was it, x? Oh, -2 minus 1. What does that equal? That's equal to -1 over -3, which is positive. That's what we're looking for. We're looking for the sign. So this one is positive. You guys try it for these other things. I want to know whether what you get is positive or negative. You're plugging in 0. Yeah, you can plug in 0 because you end up with 1 over -1. Yeah. If it were multiplying or something, maybe not. What is 0? And 2? Okay, so once you've done that, you've tested the values, you've gotten the signs. You don't actually have to write this down if you can do that math in your head of plugging it in, but you do have to show me the test values and you do have to get this business. So now, the question was, where is it greater than 0? Is that positive or negative? Positive. So anything that has positive is what we're looking for. So our solution is negative infinity to negative 1 or 1 to infinity. That's our answer. If it had been less than 0, what would our answer be? Negative 1 to 1. That would have been the only answer. So for rational ones, it's a little bit more work. You'll definitely have one on the test that you have to show all that stuff. Okay? Ready for problems? Okay, let's do them. Let's do them. We have 7. 7 of them, I think. Okay. All right. Remember the polynomial ones you can do on your calculator, or if you can do them without that, great, but put them in, get a sketch, because it's going to help you read your answer. So this is x minus 4 squared times x plus 6, and all of that less than 0. You should get some sort of sketch like that. You're going to have open circles. Why? Because it's less than and not less than or equal to. You find this number here. Why did I not worry about finding this number? Yeah, because I'm only worried about what's underneath the x-axis, so it's right there. So your answer, and it says type it in interval notation. So what's that going to be? Good. Okay. And didn't we do this one? Did we do that one? Or one, I think we did that exact one. Yeah. Okay. Well, we're moving on. Okay. Solve this inequality. 4x cubed is greater than 36x squared. If you're going to your calculator, move the 36x squared over, and so this is what you're putting in y1. So let's see if we can get a picture and do all the work and come up with the interval that is. We're looking for greater than 0. I think that's what we should, and there's a 4 under there, but I think that's what you end up getting because I brought the calculator screen there. Do you get something like that?
Yeah.
Okay. Yeah. And really, all you're trying to see is where does this graph above the x-axis? It's right there. And you needed to know that number, and you could find that. And so then you can write your answer. Your answer occurs 9 to infinity in parentheses, and that's what you'll plug in. Yes, ma'am?
Isn't there a way to do it without being on the calculator too? Like it, where if it would start negative, like looking at number 1, so it starts negative and goes positive and then it's going up, and how many times it goes through by looking at the exponent?
You're talking about all that analysis just based on that stuff? Yes, you can. And if you know that, and if you want to do that, you can. With the calculator as a tool, it's so easy to do that. But yes, there were all those analysis methods in college algebra, that we had to learn, and what is it doing if it goes down on the left and up on the right and that sort of thing.
Well, and how do you tell how it starts? Since it's a positive equation, how come it starts, how come it's upside down?
Because it's going down on the left, up on the right, and I don't keep those in my head. I'm so sorry, but this is what I'm doing, Wednesday, I'll have that piece of paper for you, though. So if you want to do it, it's great work. And gosh, when I was back at your age, I had to do it because we didn't, those things didn't exist. That's how old I am. But now they do. Okay. All right. So did we get this one? Where were we? What are we on? It was this one? So did we get that? Okay. All right. Number 4. Okay. Number 4 is this one. And so you're going to put it in as x minus 5 times that. This one. Well, let's see what sketch we get. What's the difference in this one that we haven't seen? Right there. Oh, goodness. You didn't want to see it, did you? It has an equals. So in your answer, you're going to have some brackets. We haven't had too much of that. I think I have that one actually done as well. So we're only worried about the part above the x-axis, and it's a closed-in circle, so we have a bracket, comma, infinity. We okay? Everybody good? I think I have the other, there's 3 this way. Let's see what we got. All right, you guys seem to have this down. So, these notes are there. You can see them. There's that one. Let's do the number 7. Let's do number 7 because it's a rational one. And that is one that we need to go over. Okay? All right, so when we do it, what is the first thing? We want to solve the top and the bottom. So we've got -3 and +7. And so that's what we're going to put. Well, I already have the answer for you. Let's go ahead and work that, though. All right, so let's draw our line. And we'll have x equals -3, x equals 7. And then I want to define the interval. So what's it going to be here?
-3.
And then sometimes you might have 2 solutions on the top or the bottom. Just means you're going to have more numbers on your line and more intervals. That's all that means. Okay, then we're going to have some test values. So I would say maybe -4. Again, here the perfect one is 0 because it's easy to plug in. And then 8. If you pick different numbers, that's fine. They just have to be in the interval. And then the signs, I'm going to let you come up with those. I want you to come up with the positives, negatives, whatever. Did you say this one? And they don't always alternate. I mean, often they do, but be aware. And then positive. So when you do that, and remember you're plugging into the original, and you get that, what are we looking for? We're looking for where is it less than 0? So right here. So your answer is -3 to 7, so that'd be that one. And it's got parentheses around it. Note they give you the same numbers with the brackets, but it's this one. Okay. I think that's the last one. You guys can practice the others. Any questions? And you know what I think I did?